Hey guys, Ray from loveyourrv.com back with you again. So I'm back to explain an upgrade I've done to my boondocking system. So over the years I've slowly changed my boondocking system, evolved as I've added things. I started out with 200 watts and then went to 400 watts, then 600 watts. I added a ground panel for 700 watts. So last year, Bogart sent me a couple solar panels to review, and that pushed my rooftop solar up to 940 watts. And then I still had a 100 watt ground array, but I've also been getting a lot of folding solar panels. And recently, about 3 weeks ago, I installed the Bogart MPPT solar controller. It was 40 amp. So it's time to redo all my solar stuff and DC wiring. So I'm going to upgrade all that and change things around. So I thought I'd do a little block diagram before we start looking at the actual physical stuff, just so you can get it in your mind what I'm doing. So on the roof right now I have 940 watts. Let's call that the roof solar array. And then on the ground, I'm going to have about 500 watts, and it's going to be, I have a 100 watt Renogy panel, and then I have some Jackery folding panels, and also have a Lensun folding panel. So what I'm going to do is, because I've introduced this Bogart MPPT solar controller that's 40 amps, I still have my good old Bogart PWM solar controller that I've used for many years, must be about 6 or 7 years now. I'm going to take that and I'm going to make it the controller for the ground array. So you can see when I have it set up, I'll have the roof array feeding the Bogart 40 amp, and I'll have the ground array feeding the Bogart 30 amp. Now, why would I want that? Well, I can take advantage of all that solar, but also the ground array, I really like that in case we camp in some trees or something. So, you know, if we park under trees, the roof array might not get much solar at all, but I can, with the extension cable, I can take the ground array and put it out into the sun, and bam, Bob's your uncle. I have some good power coming into the RV. I have two other charging sources as well. Up front, I have a 60 amp IntelliPower converter charger that I can use with my generator. And another alternative is my truck alternator. I installed this last year. I bought myself a Renogy 40 amp DC to DC charger. So when we're driving down the road, I can be putting power in through the truck's alternator. And all that goes into my 315 amp hour lithium bank Line Energy batteries. So that's kind of gives you an overview of what I'm attempting to reorganize all my boondocking system, kind of clean up the wiring and move things around. So let's get to it. Okay, so let's go through the latest incarnation of my boondocking power system. Over here we have my chargers. So like I said, I installed this charger a little while ago, the Bogart charger, which I'm testing out this summer. It's a 40 amp MPPT charge controller, and feeding it from the roof, I have 940 watts of solar panels on the roof feeding that charger. So when I installed that charger, that left this Bogart controller as a spare. This is the SC2030 from Bogart Engineering, which I've used for years and years now. And it's a 30 amp charger, a PWM charger. So I thought I'd reuse this as my ground panel charger. So over the years I've always carried a 100 watt ground panel when boondocking, and in the last little while I've been testing those, you know, those solar generators like Jackery and the Himson, and they've always sent along these folding solar panels to do the tests with. So now I have quite a few folding solar panels. So I thought, when I'm boondocking, that would be nice to set up a ground array. Especially if I'm in trees or something like that, I could actually move the ground panels out and still get some solar even though the roof may be blocked. So I've wired this one into my existing ground panel wiring. That's this black cord here. It's actually a 30 amp power cord that I cut up and used for my ground panel. So it feeds into there, and then the output from it is going to go into the same line as this DC to DC charger, which I installed. I think last time I was down south I put this in. This is to charge off my truck's alternator. So I set up a system to feed this while I'm driving so I can get 40 amps of charging power out of that. So I just conveniently used the same wiring. You can see the positive meets up with the positive there, because I'm not going to be running both these at the same time, although you could, but usually if I'm driving I'm going to be running this and not my ground panels, of course. They'll be put away. And then just out of convenience I've run the ground negatives to the chassis frame, and then that goes along and it gets picked up and goes back into my battery bank. So that's those 3 chargers. Between these two, if I'm running max, I should be able to get 40 amps out of this and 30 amps out of this for a combination of 70 amps. And then there's this one, which is my IntelliPower charge converter that I use for generator charging. And you can see the input comes out of this black that I've hooked into this AC cord, and that AC cord goes around the batteries, and then there's an input here so I can plug my generator into there. When I plug my generator into there and fire it up, this thing can put up to 60 amps of charging right here. So I have quite a different array of different chargers to work with. Also decided to take this old phone that I had kicking around and use it to look at what's going on when I'm in here. This is part of my trimetric battery monitor system, and this is the Wi-Fi module, and you can see right now it's showing amps, but it will show solar current right here. It'll show me the solar current coming out of this thing. This has its own display that I can see the current, and then also I'll see the total amperage going into my battery bank that's being read by this shunt here on the negative side. And as far as fusing, all the panels on the roof are have fuses. Each panel has a fuse, just in case one of the panels was to fail. I'm not going to bother fusing the panels on the ground array because they won't be on my RV. They're going to be on the ground, so if one catches fire it won't be such a big deal. So it's kind of a pain to go and fuse each individual panel, but for safety reasons on the roof I did that. I put a fuse to each panel, just in case one fails and shorts and all the other ones start backfeeding into it. There's a remote possibility it could cause a problem. Then you can see there's a breaker for each of these. This is a 40 amp breaker, and that's going to be for my DC to DC charger that's coming off the truck alternator, and then it also will share with this. So I can't really run both of these at the same time. If I was running 40 amps and 30 amps, of course I'd blow that breaker, but I don't see any scenario where I'm going to really need to do that. So just to save money, I'm just going to share the breaker. And then for this MPPT controller, it's a 40 amp, and that is a 40 amp breaker, and so far it hasn't been a problem. I haven't blown it or anything like that. This doesn't need any breaker. It has its own fuses right here. And then this breaker you see is actually 2 lines here. One line feeds my RV circuits, so the OEM stuff was hooked up, and I just have this breaker basically as a switch. It's an 80 amp breaker, but it's fused further down the line. If you look at the OEM stuff over here, this is what they had from the battery down to here, and they have 2 fuses in parallel. I think they're 2 30 amp fuses to make a 60 amp, because there is a 55 amp charge converter in the rig, so I'll just leave those as be. They can do their job as protecting the wire, but I just decided to put this in as well just to have the switchability, and gives it an extra bit of safety. And then up here there's just a 30 amp fuse, and that is for my port that I put on the side of the RV for my air compressor. And it also is powering the switch for my awning I put in a manual switch for the awning and the awning lights, so that's kind of protecting that line there. Then my batteries, I have the 3 Line Energy batteries, 315 amp hours. So I put a fuse right on this terminal, and that's a 200 amp fuse. So that's more than the max my system uses. So that's kind of like the fail-safe fuse. If anything goes wrong outside the battery box, like you can see where it comes up here, if something were to come along and short from there to say the negative bus bar right across, that would protect that wire from getting too hot. Also have a 175 amp fuse here, and that's basically for the inverter here. Still got my old 1000 watt Motormaster eliminator. This inverter's 10 years old now, and it's basically been on almost the whole 10 years, but that's kind of on the list to upgrade when I get some spare cash. I wouldn't mind putting in a 2000 watt inverter, but we don't really use enough stuff to need a 2000 right now, especially since I carry a generator anyway. So I'm kind of just holding off on that. Maybe if I get some spare cash, I'd like to upgrade that as well, since now we have the lithium and they can put out a lot of energy. And then on the output of the inverter, I just run it into 2 outlets inside. There's one outlet that basically sits in the living room and one in the bedroom. Just think of them as glorified extension cords from this inverter here. I did a video on that where I explained what I did there. So that's about it. Let's get a test and see. Hopefully the sun will come out and we can kind of see if we get how much energy we can get. I'm going to go lay out 500 watts of solar panels on the ground out there. Let's go show you that. So here's what I've set up for my ground panel test. I got 2 100 watt Jackery folding panels, and I also have a Lensun 200 watt solar blanket, they call it. So that would be 400 watts. And then I'm also hooked into my Renogy 100 watt ground panel that I've been using for a few years now. So I've just paralleled them all together, kind of cobbled together from what I have kicking around. I'm going to have to set up kind of a connection junction thing to quickly click them all together when I'm boondocking. And then I have it run through this into my cord that I made a long time ago for my ground panel, and that just connects right there and goes through the pin box. Well, got a bit of sun coming in. See 18.9 amps to the battery. Check the solar. There we go, 21.2 coming off those ground panels right now. 19, so it's popping back and forth. There's still some clouds in the air, but not too bad. They're just lying flat anyway. So I think maybe I'll go and I'll turn on my rooftop panels and we'll see the combined solar systems at work. Okay, a lot of reflection, but 39.97 amps coming on that controller. Combined, we got 56 amps. Ground panels are putting out 17.2. So you can see the combination there. As the clouds go over, so I'm up 57.8 amps, 58 amps. Well, that's pretty cool. So that's 2 different controllers running 2 different arrays, charging at the same time. A lot of people ask, can you run 2 chargers at the same time? It's a common question I have. Can I have my solar on? Well, I'll say my charge converter is on, and yes, you can. Most modern systems can handle it, no problem. You might want to look in the owner's manual of your chargers, but basically the battery is the system that sets the voltage, and then the chargers just really react to that. So if one charger is charging higher than the other one will just back off its charge. They work it out. So yeah, I'm up to 58, 59 amps, almost 60 amps. So Getting pretty close, even though I have basically my panels that are flat, not even tilted to the sun, and we got clouds coming over, and I'm getting close to 60 amps, so it's exactly what I wanted things to do. Also, I did a little mod on this. I added behind here, I added some aluminum square bar to mount it on, just to pull this controller a little further away from the wall, and then that aluminum will add a little bit more heat sink to it, and being away from the wall I'll get a little more air behind there, because I did find this one can get pretty hot when it's running flat out. This controller barely even gets warm. It's a really efficient little controller. I decided to fire on my charge converter just like I would have my generator running. Now I'm up to 84 amps of charging power. I noticed when I turned this on, it did knock this down to 26 amps and 12, so that the solar chargers did drop a bit. They could be kind of not really set up in the same voltages. That's the only thing, is when you get multiple charges going, if they're slightly off in voltage compared to each other, you can get some difference. It's not like they totally add together, but still 80 something amps is pretty good. And my battery bank can take it, because there's 3 lithium batteries. They actually have max 100 amp charging each of them, so I could actually put 300 amps into this bank, but they kind of say around 45 or 50 is optimal, so that means around 150 amps. So I'm not even anywhere near taxing these batteries at all, even charging them at that high rate. Okay, job complete. Got the new controller in, all the wiring redone, and things mounted nice and neatly. You can see what I carry in here. I try to carry things below all this because I don't want stuff flying around there and shorting out on stuff, and I try to make sure everything is really tightly packed in there. And on this side I don't put anything that's going to be metallic or anything that could short out as well. This is my battery box. I have it clamped down with some straps. I also run a cable lock through the lid just to kind of make it a little harder on people to steal my batteries if that's what they're trying to do. And maybe you ask what this is. This is actually a gizmo for remote operation of my awning, my slide out, my front landing legs, and a light. Now this I'm going to be having a video out pretty soon, because I'm going to replace this. A little while ago I noticed suddenly things would go out but not come back in. And inside this thing there's some relays, and I think maybe one of those is bad or something in electronics, but it's totally sealed. You can't take it apart and repair it. So I kind of looked around. They had this particular one on a site called GAM Electronics, but then I kind of went through links and I found out Lippard have also sold these, but they were obsolete. I contacted them, and they're going to send me out a newer generation that I'll be able to do the same thing with. So I'm going to take this out and install the newer generation of remote control. So stay tuned for that in the future. Won't be too long before that, maybe a couple weeks. Anyway, I hope maybe you found that useful if you're wiring up solar or chargers, or just were interested in how my system's put together. Till next time, Ray from loveyourrv.com. Cheers, folks.